When you board a plane or buy a new computer, do you stop to think about the materials it's made of? Most of us don't. Materials are in the background. But consider that advances in materials have preceded almost every technological leap since the beginning of civilization. And then thank Jim Williams for his considerable contributions. Internationally recognized as a leading authority on titanium, Jim was one of the first researchers to demonstrate its potential applications in aircraft. Among his prestigious honors, he is a member of the National Academy of Engineering and a fellow of ASM International and the Metallurgical Society of the American Institute of Mining. Jim has been a leader in industry and academia and a lifelong mentor to students. And it all started here at the UW.
Well, I always think first of the way Jim is physically. He played football for the university and in fact came there, I think, originally on a football scholarship. We met at the University of Washington when we were both grad students together.
When he got his PhD from here, he took a year off from Boeing. I was still there, and I would work till 4 or 5 o'clock, and then he would come in at 5 and work till midnight and get through his thesis, and he finished it in a very short time.
Jim, above all, I think is an amazing person. He's a brilliant engineer, a tremendous advisor. He's smart, has tremendous foresight.
He's best known for his pioneering work in titanium.
Titanium alloys have two big areas of application. One is in aerospace because they're relatively light for their strength. So you get a strong material at some weight saving. The other area where they're important is corrosion. They're very corrosion resistant.
But also biomedical applications. Jim's been recently working on beta titanium alloys that are specifically for implants that don't have vanadium in them. Jim's early career in industry focused mainly on structure property relationships and titanium alloys. And this was back in the day when industrial companies did a lot of practical and applied research.
And Jim and I did some of the first work in really defining what happens with stress corrosion cracking of titanium alloys on the supersonic transport program. His primary contributions there have been in the engine game. And in fact, on our new 787 airplane, the GE engine is using what we call gamma titanium aluminides. And this is the very first application of aluminides in structure. And that has a very significant effect on fuel efficiency. So that means we're burning less fuel, less emissions, all kinds of things, which could be a very big factor, the way things are going these days.
But he's worked more broadly than that, other areas that in materials we call microstructure property relations, how you get the properties of materials by the way you prepare them.
Even before he started teaching in academia, he was already an acknowledged expert within industry. After being at Carnegie Mellon for years, including being dean, he went off and headed the group at General Electric.
He had about 450 employees under him. He was responsible for R&D development, getting new materials on engines. His group was responsible for material specifications, processing specifications, solved dwell fatigue problems that have been occurring in engines. Under his guidance, they have resolved that issue and changed the processing, so that's not an issue.
I think the most outstanding achievement in Jim's career has been his work on dwell fatigue, which causes substantially earlier failure in rotating titanium components in gas turbine engines. Although it's all behind the scenes action, the work that he did by bringing together all the industrial partners as well as universities and incorporating careful experimentation and numerical modeling, they were able to identify this and come up with a means for processing titanium by a different route in order to mitigate this effect.
Other industries that Jim has impacted have included the chemical industry, the nuclear industry, including our nation's defense and the nuclear weapons industry. After my PhD, I worked at Los Alamos National Laboratory, and Jim was coming out there on a regular basis to consult and be on oversight committees for the Material Science and Technology Division at Los Alamos. I think being dean of both Carnegie Tech and Ohio State gave him an impact in the education field that's not necessarily one that many people could claim.
He was very good at helping them begin to see how you deal with data, how you deal with the observations that you make, the photographs that you take, all those things that students have to begin to see what it means. Of course they know in a way from their coursework, but you have to begin to interpret new things for yourself. And that's something Jim worked hard at, and I think it was very successful. I think when you talk to Jim students, you see that. They're very warm about Jim, and I think rightly so.
I had a key to his office. I could walk in and, anytime and talk my mind with him freely, and he gave me tremendous insight, introduced me to a million people, and opened up a lot of opportunities and for the future.
And learning from Jim how important it is to be open-minded, to be an active listener, and to try and help younger people as they work through some of the issues as they start their careers has been a big help to me.
He brings a very unique aspect into the metallurgy department, in that he does have all that industrial experience. So he can help guide the research towards solving real world problems.
Congratulations, Jim. No one's more deserving of this award than you.
Jim, it's a pleasure to have this opportunity to congratulate you, and I think I do that on behalf of the dozen or so graduate students that are of the era of Carnegie Mellon.
Jim, I'd like to say congratulations, and I can't think of anyone that deserves this award any more than you do.
I think this is a much-deserved honor. I know how much the University of Washington has always meant to you, Jim, and this honor, I'm sure, is important to you along with all the others.
Tonight, we present the 2010 Distinguished Achievement Award in Academia to Dr. Jim Williams, whose work has been at the heart of today's materials revolution.